What is ordinary or standard induction is where you first prove p to 1, and in this case, it would be proving this, the first case, and then you prove that for any p to the n, or pn, it implies that the next case, pn plus 1, is true, right? So in this case, for any, like, let's say these two circles, which represent each case, let's this be n, and this be n plus 1. You prove that for some n, this implies that the next case is true. So applying this to the top, you get that this implies the next, so that is true. And since this is true, this implies the next is true, which is also inductive. And the next case is also true, and so on forever. Now, what about complete induction? First, you prove your base cases, which in some cases is P1. What's different about complete induction versus normal induction is where you don't just assume, let's say this case is true to prove the next. You actually assume all of these cases before are true. How does that work? Well, let me show you. The first case starts like this. Really, the first case is true. And you assume all of these cases before. In this case, there's no numbers before. But then the next is true because n implies n plus 1. And you can prove the third case because all two of these are true before. It's not just you're pulling it out from nowhere. You actually already assume that these two are true. So then it implies the next is true, and also so on. That's why complete induction is stronger than ordinary induction, because you can use all of these cases before to prove the next, and not just the previous. In some cases, you will not have to need all the cases before, and that's why ordinary induction is used. But complete or strong induction allows you to solve more complicated problems with induction. I hope this helped.